Hi, what is the value of x given that you have x to the power of 5 equals 1? So let's have it to the solution. So from here, it is obvious that we can have x to be equals fifth root of 1, and this implies we have x to be equals 1. But let's also find other complex solution. Because from here we have the power to be fifth, meaning that you must have 5 answers. So we've got that one, we've got this one. So let's look for the other one. Then let us use the division of polynomial, where we are going to have this as this. So for the first one, we have x to the power of 5. So we are going to have it to be 1, 0 for the s to the power of 4, 0 for the s to the power of 3, s to the power of 2, x. Then, when we have this as x to the power of minus 5, x to the power of 5 minus 1 to be equal 0. Here will be minus 1. So we're going to have minus 1 here. Then let's take this one that we have here. Let's take it to this place. Then from here, when you say 1, let's take this one, take it down like this. 1 times 1 will give us 1. So 1 times 1 will give us 1. We add it to this one, we have it to be 1. 1 times this one again will give us 1. Add it to this one will give us 1. 1 times this one again will give us 1. Add this one together will give us 1. 1 times 1 again will give us 1. Add this together with this, we have it to be 1. 1 times 1 again will give us 1. Add this one, we have it to be 0. So all these are the coefficients of, this one is the coefficient of x to the power of 5. This one is coefficient of x to the power of 4, x to the power of 3, x to the power of 2, x, and the constants. So now, since we reduce this one with a factor, x minus 1 equals 0. And we have this, so meaning that we have x to the power of 5 minus 1 to be reduced as x minus 1 multiplied by, this one will now be the coefficient of x to the power of 4 multiplied by x to the power of 3, plus x to the power of 2 plus x plus 1 as this. So this one will be the coefficient of x to the power of 4, x to the power of 3, x to the power of 2, x to the power of 1, and this one will be the constant. So far here is the 0. So now from here we have x minus 1 as this multiplied by x to the power of 4 plus x to the power of 3 plus x to the power of 2 plus x plus 1 as this to be equals 0. Of course, this is a polynomial, but this particular polynomial, we can express this as the product of two quadratic equations. So, but we have to take note that when we can name this as x to the power of 2 plus, we close the bracket as this, again multiplied by x to the power of 2. This times this will give us x to the power of 4. But we don't know, okay, here is plus and here is plus, here is plus. So when we have here to be plus 1, we also have here to be plus 1. We believe that 1 times 1 will give us 1 back, but we don't know what is here. Let's put it a parameter ax. Let's put here to be the parameter bx. So when we open the bracket, from here, we are going to have this times this. We have it to be x to the power of 4. So this times this, we have it to be bx to the power of 3. This times this, we have it to be plus x squared. This times this, we have it to be ax to the power of 3. This times this, we have it to be abx squared. So this times this, we only have ax. This times this, we have it to be x squared. This times this, we have it to be plus bx. This times this, we have it to be 1. Then from here we have x to the power of 4. Then we have this one to be x to the power of 3, x to the power of 2, meaning we can have it as a plus b, all in bracket to the power of x to the power of 3 as this. So we have x squared here will be 2. We have this one to be AB, so we can have this as AB plus 2 multiplied by x squared. Then we have BX, AX, so meaning we can have this as A plus B to be equals x, then plus 1. Now, to now express this as the product of this, meaning that the coefficient of x to the power of 3 here is 1, this implies that A plus B must be equal to 1. Likewise, as we have the coefficient of x to the power of 2 to be equal to 1 here, this also AB plus 2 must also be equal to 1. And we also have AB to be equal to 1 already for this. So now when you solve this simultaneously, we are going to have A to be equals 1 positive or negative with 5 divided by 2, and we are going to have B to be equals 1 minus plus with 5 divided by 2. Now when we now recall that we have x minus 1 multiplied by this x squared plus ax plus 1 multiplied by x squared plus bx plus 1 to be equals 0. You know that this equals x to the power of 5 minus 1. Then, meaning that we are going to have x minus 1 multiplied by x squared plus our a equals this 1 positive or negative root 5 divided by 2 multiplied by x plus 1 again multiplied by x squared plus 1 minus plus with 5 divided by 2 x plus 1, everything equals 0. So from here, for this expression to be equal 0, is either we have x minus 1 equals 0, where we have it before as x will be equals 1, the real solution, and likewise, or we have x squared plus 1 positive or negative root 5 divided by 2 multiplied by x plus 1 equals 0, where we are going to have the value of x to be equals. But let's gradient ratio phi to be equals 1 positive or negative root 5 divided by 2. So we are going to have x to be equals minus phi positive or negative root of 5 squared minus 4 divided by 2. And again, we have this to be the solution. So if you are new here and find this video interesting, don't forget to share, like, comment, and subscribe to our YouTube channel for more maths tutorial videos.